Welcome back, ladies and gentlemen. So today I want to look at the effects that our two variables m and b have on our equation of the line. So just as a reminder, our general equation of the line is y equals mx plus b. Now these two variables, m and b, account for the slope and the y-intercept on our equation of the line. Slope and y-intercept will essentially define what any line is. So we give this equation of the line, this form of the line, a special name. This is called the slope-intercept form of the line because we get the slope and the y-intercept directly from our equation. So I really want to dive in and talk about these two parts of our equation in a little bit more depth. Let's start with slope. Now, when we're looking at the slope of a line, there's essentially four different lines we can have. We can have a positive slope. You can see that's the red line here going up and to the right. Or we could have a negative slope. That's the green line going down and to the right. So positive up and to the right, negative down and to the right. That will be 98% of the lines that we cover in this course. However, there are two extreme cases, two special cases that we're going to look at as well, and that is if we have a perfectly vertical line and a perfectly horizontal line, and what does that mean for the equation of the line. First off, let's just make sure we understand how we can pull out our values from our equation. So I have a few examples here. So for example number 1, we have y equals 3x plus 2. We want to figure out, well, what is the slope and what is the y-intercept of this line? Remember that our equation is y equals mx plus b, where m is the slope and b is the y-intercept. So we're looking for what number has the x with it. That'll tell you what the slope is, and then the other number must be the y-intercept. So in this case, y equals 3x plus 2. We can see that the m value is 3, so we have a slope of 3, and the b value is 2. So we have a y-intercept of 2. It's important to note that our slope is not 3x. That's a common mistake students make. It's the number in front of the x, but we do not include the x itself. Continuing on to the second example, y equals negative 1/2 x minus 3. So our slope is negative 1/2, and our b value is negative 3. The negative here belongs to that b value. In standard form, y equals mx plus b, we assume the y-intercept to be positive, but if that ends up being a negative here, it means the y-intercept is negative. So in this case, our slope is negative 1/2, and our y-intercept is negative 3. Going up to the top right, our slope is 3/4, and our y-intercept is 7. And this one I purposely made a little bit tricky. The slope in this case is not 1. We often write the slope as being the first number, but again, the slope is the value that goes with the x. It's the coefficient of the x. I could very easily rewrite this, just switching places here. This is negative 4x plus 1. Remember that negative belongs to the 4. So in this case, my slope is negative 4, and my y-intercept is positive 1. So let's deep dive now into what happens when we actually change these values. To do that, I'm going to actually bring in Desmos so that we don't need to do all these graphs by hand. And let's look what happens when I change my m value to begin with. So the line we're looking at right now is just the line y equals x. So remember, there's a 1 in front of the x, so this would be a slope of 1. And there is no y-intercept, or we could say the y-intercept is 0. And we can see that on the graph. If we look, we can see that the line is passing right through 0, 0, the origin. So let's go ahead and look what happens when I change my slope. Let me turn on this line, y equals 2x. So notice the y-intercept has not changed because this is still y equals 2x plus 0. I've only changed the number in front of the x. I've only changed the m value, which is our slope. And we can see this line has gotten steeper. If I turn on y equals 3x, our line gets steeper still. Let's go the other way. Y equals 1/2 x. We can see the line gets a little more shallow, a little more flat, and y equals 1/5 x, like that. So you can see as I change my slope, as m gets bigger, the slope gets steeper. As m gets smaller, the slope becomes less steep. Now, what if I turn on some of these negative values? So what about y equals negative 2x? Well, by the looks of it, when I turn on a negative slope, now my line is going down and to the right. If I compare that against y equals 2x, so I have y equals 2x and y equals negative 2x, you can see they're essentially the same steepness. However, one is going up and to the right, one is going down and to the right. If I turn on y equals negative 3x compared to y equals 3x, same steepness, one up and to the right, a positive slope, one down and to the right, a negative slope. But it still maintains true that as this number becomes larger and larger, right, -2, -3, the line gets steeper and steeper. It's just going down instead of up. We can do the same thing with our negative. Y equals -1/2, y equals -1/5, and that would just keep getting more and more shallow as that number gets smaller and smaller. So that's what my slope does. Now what about the y-intercept? So in this case, I decided to look at the line y equals 2x, again plus 0. I technically don't need to write that plus 0. I just put it in there so you could see what's going on. Well, what happens if I change this to y equals 2x plus 1? So the slope is staying the same. I'm just changing that y-intercept. So plus 1 looks like this. Plus 3 looks like this. So you can see the line is essentially being shifted up. And if I click on the y-intercept, we can see y equals 2x plus 1 crosses through at y equals 1. Y equals 2x plus 3 crosses through at y equals 3. If I turn on this one, y equals 2x minus 2, and we can see it's crossing the y-intercept at -2. So all the lines have the same slope. You notice they're all parallel lines. They'll never intersect one another. They're all equal steepness. All I'm doing is shifting my graph up or down depending on what my y-intercept is. So if we look at just a general equation, I put a couple sliders in here and we can see what happens. So as I change my slope, we can see what's going to happen. So here's our standard line, y equals mx, or y equals 1x in this case, a slope of 1. If I make this bigger and bigger, it gets more and more steep, and I bring this over and it starts getting super steep, almost approaching a vertical line, but not quite there yet. And if I go down into the negatives, it does the same thing, just getting more and more steep, however, going down and to the right. And as I change my b value, I can just slide my graph up and down depending on what the b value is. So if I'll put it in some random spot, you can see my b value is 3.6, and you can see my line passes through the y-axis at exactly 3.6. So let's put this down now. What does this mean? Well, when m gets larger, it means my line is going to get more and more steep. If m gets smaller, the line is going to get more and more shallow. So that's going to tell you about the steepness of the line. And then we're going to look at, well, is m positive or negative? If m is positive, then we're going up and to the right. If m is negative, we're going to be going down and to the right. In the case of our y-intercept, what did we just see? Well, as b gets larger, the line appears to shift up. As b gets smaller, the line appears to shift down. Whatever that b value is the value of the y-intercept. So we can plot that right on the graph if we need to. Now, earlier I did mention those special case scenarios, the vertical and horizontal lines. So let's look at what's going to go on with those. The easiest one to start with is when we have a horizontal line. So if I have a horizontal line on my graph, something like this, would be when we have a slope of 0. If you recall from our discussions earlier, we know that our slope is delta y over delta x, or I could say it's rise over the run. Well, in this case, if I highlight 2 points, here's the point 4, 6, and over here I'll just pick another random point. Here's the point -4, 6. I could choose this point as well. This would be the point 0, 6. Over here, if I were to continue my line, would be the point 8, 6. Notice what they all have in common. They all have the exact same y coordinate. They're all 6. So when I do my rise, you can see, well, there is no rise. So the rise would be 0. And the run, let's say I'm going from my 2 original points, from here to here. I'm going from -4 to +4, so I'm going over 8. So my rise over run is 0 over 8, which is, of course, just 0. So this is going to be true for any horizontal line. So putting that into our equation, if we know the slope is 0, that means y equals 0x plus b. Well, 0 times x is just 0. So we're left with just y equals b. So our equation of the line is only going to be the y-intercept. In this case, you can see my y-intercept is occurring right here at 6, and we can see every single coordinate has a y-coordinate of 6 to go along with it. So we would call this line simply y equals 6. If I move my line down, this would be the line y equals 2. Down here, y equals -4, y equals -10. Just that simple. The vertical lines are a little bit more complicated because the slopes here are what we call undefined. So let me put my line right here. Let's look at the coordinates. We'll highlight some of the coordinates the same way. This coordinate right here is at 5, 0. This coordinate right here is at 5, -4. If I want to calculate my slope the same way I would have done before, m is equal to rise over run. In this case, my rise, I'm going from -4 to 0, so I'm going up 4, and my run is nothing. I'm going from 5 to 5, so I'm doing 4 divided by 0. Now, if you try to do this in your calculator, 4 divided by 0 is undefined. In math, we are not allowed to divide by 0. So what does this mean? Well, that vertical line, it's so steep, we wouldn't even really say it has a steepness. It's a 90-degree angle. We could say its slope is infinitely high, or we can just call it undefined. So if we have an undefined slope, what does that mean? Well, it means I can't really plug that into the equation. My equation of the line, y equals mx plus b, I have nothing to plug in for m. I can't write in undefined. So let's go back and look at some of the coordinates again. We can see the x-coordinate here is 5. The x-coordinate here is 5. Again, if I were to continue my line, this would have the point 5, 6. That has an x-coordinate of 5. Down here would have the x-coordinate of, or the coordinate of 5, -10, but again, x-coordinate of 5. Anywhere on this line always has an x-coordinate of 5, so we'll just call this line x equals 5. So when you have a vertical line, it has kind of a special case where we just say x equals, I'll call it c, some number, whatever that x number is. In this case, it's 5. If I were to move this line, let's try something else. Over here, I would call this line x equals -6. Over here, x equals 2, x equals 8, and so on. So these are our two special cases, so you'll want to pay attention to those when you have horizontal or vertical lines. Horizontal lines simply have a slope of 0, So you can just plug that into the equation and off you go. Vertical lines, a little bit harder. You can't plug in the slope, so you just have to remember that it's x equals some number. All right, so that's all we need to speak about right now. As always, you have some practice questions waiting for you online, and I wish you luck.